Well, hi homeschoolers. Today we're going to start a new unit that'll take us to spring break, and it's about sound waves. And remember, we talked all about transverse waves like light and water waves. Now we're talking about longitudinal waves, ones that move parallel to their vibration. And we're going to talk today about how to measure the speed of sound, or how to calculate it. And there's a few different ways. First of all, sound requires a medium. It requires water or steel or air. It requires some sort of material to vibrate through. And it's dependent on temperature, because as particles move faster, that energy can be transferred among faster moving particles more quickly. So the speed of sound is 330 meters per second, plus it goes up by 0.6 meters per second for every degree Celsius. So at 0 degrees Celsius, it's 330 meters per second. It's about 22 degrees in the room today, so you can figure out pretty easily, just by plugging 22 in there, what the temperature or what the speed of sound is in the room today. We can also measure the speed of sound by just measuring how far it goes and the time it travels. It's a normal velocity equation we've been doing all year. And then also, just like a wave, you can measure the velocity as the wavelength times frequency. And what we're going to do today is we have a graduated cylinder filled with water and then a resonance tube. So we're going to set up a resonance pattern inside this tube, and it's already marked with the distances, and we're going to measure the wavelength inside this tube. Sound waves are going to go in the tube, they'll hit the water and bounce back out. And what we're looking for is, if you'll remember standing waves when we did them on the string, they have antinodes and nodes. And one wavelength is just like it's always measured. It has from one point back to that same point in the wave, so crest to crest, trough to trough. Today, what we're going to get inside of the tube is just 1/4 of a wavelength. So whatever we measure as a wavelength on the resonance tube, we'll just have to multiply by 4 to get the actual wavelength of the sound wave. But we're going to be using some tuning forks. We have an A, a B, a C, a D, and an E musical notes, and I'm just going to strike them. I hope you can hear that over the iPad microphone. And I'll just show you how this works. This is an A. It's 426.7 hertz. That's vibrations per second. And we're going to set up a standing wave. So we're going to be listening for that constructive interference pattern. Where it's really nice and loud. Didn't quite get that. Okay. So that's the loud point, the constructive interference, and that was at 0.2, 20 centimeters, or 0.2 meters. And remember, that was only 1/4 of the actual standing wave was in the tube, so we have to multiply that by 4. So the wavelength was 0.8 meters. And we'll do that for all 4 of them. This is a B, 493.9 hertz. Nice loud spot there. Hang on. It's about 0.17 meters. And then you have to multiply that by 4, and that would be 0.68 for the actual wavelength. Okay. And then I'll set up the other standing waves. This is a C, 512 hertz. So this is, as we keep increasing the frequency, the wavelength should go down. So as the frequency goes up, the wavelength has to go down, because the sound is the same. The speed is the same for all of them. Right there, 16 centimeters, or 0.16. So 0.64 is the wavelength. We'll go to a D, 293.7. This is a lower frequency, so it should be a higher wavelength. It's about 0.29 meters. ahead, 1.16 is the actual wavelength. Remember, we only have a quarter of the standing wave in the tube, so we have to multiply by 4. And then an E, 329.6. Listen for that loud constructive interference. It's like about 26 centimeters, or 0.26 meters. It's 1.04 centimeters. So your job today is going to be, we have the frequency, we have the wavelength. I want you to figure out what is the velocity of the sound for each of them, and then add them all up and find the average velocity, and then compare it to the equation that's dependent on temperature. So 330 plus 0.6 times 22. See you next time.